All right, I am back and ready for the next lesson. This lesson is all about properties. So properties is a word in English that can mean a number of different things. Sometimes your neighbor might yell, "Get off my property!" That's not these kind of properties. Sometimes you might say to somebody, "Hey, don't touch that, it's my property." Also not this kind of property. These kind of properties are rules, or sometimes I like to call them math truths. So they are always true in math. So these are things that, ways that numbers behave that will always happen. And so the first one that we're going to talk about is the associative property. And you might have heard the word associate, your parent might say, "Oh, like, I don't want you to associate with Mrs. Langton. She's not a good kid," which just kind of means don't hang out with. And so the associative property is all about who numbers are hanging out with. So in the associative property, numbers are going to hang out with each other inside parentheses. So I might have something like 4 plus 3, and 4 and 3 are friends hanging out in the parentheses, plus 2, and 2 is not in the parentheses. And it is a math truth or a rule that I can change which numbers are hanging out, but it won't change that it's equal to this before I change the parentheses. So I can change the parentheses, not the order of the numbers. So I'm still going to have 4, 3, 2. 4 plus 3 plus 2. But now the 3 and the 2 are hanging out, and they're actually still equal. So before we solve it, what I'm going to do is I'm going to write that the parentheses moved. So different numbers are hanging out, or different numbers are together. So now let's solve that and show that it really is in fact equal. So based on order of operations, I would do the parentheses first. So 4 plus 3 will give me 7 plus 2. And over here, I would do the parentheses first, so I would get 5. 3 plus 2 is 5, plus 4. And 9 is 7 plus 2, and 9 is 4 plus 5. So they are still equal. Right? So it didn't matter that I changed where the parentheses were, I still get the same amount. So that's what this symbol means right here. So this expression here is equivalent or equal to this expression here. So still equal. This property actually also works with multiplication. So if I do another example of, let's have the 4 times 3 times 2 and equals 4 times 3 times 2. So I have two expressions, and right now they're exactly the same. So now let's have them hang out with different numbers. So let's have the 3 and the 2 hang out first this time. And then the 4 and the 3 will hang out over here. So you can't have the 2 and the 4 ever hang out because they're not next to each other. So we couldn't group those in parentheses. So the parentheses moved. So let's see whether or not it's still equal. We'll sort of prove what Mrs. Langton just said. So I do the parentheses first. 3 times 2 is 6 times 4. 4 times 3 would be 12 times 2. 4 times 6 is 24. 12 times 2 is 24. Ta-da! They are still equal. Okay, so I moved the parentheses, but it still works. So this rule works. The associative property is a math rule. A math rule. That was math truth plus math rule combined. Maybe that's what we should call it in class. A math rule. A math truth The associative property shows math truths for addition and multiplication only. This does not work for subtraction or division. Okay, so the rule says, or the trule says, if we change what numbers are grouped in the parentheses, it will not change the value of the expression. And then I put a little plus and a multiply symbol to remind you that this is adding and multiplying only. Okay. Our next property is called the commutative property. Practice saying that out loud or whisper it to yourself. This is not called the commutative property. And so I like to get kids to kind of remember this one by thinking about commuting. And so probably a lot of your parents commute to work unless they work from home like Jamie does. So if you commute to work, that means that you get in your car or get on your bike or go to the bus and move in some way to get to work. And so that has to do with this rule or trule in math because the numbers are commuting or the numbers are moving. So let's write to commute means to move around. So our numbers are going to do the commuting. So think of that when you're saying this property. So it's not community or commutative. It's commutative, and they're going to commute. All right, so I'm going to bring our trusty 4, 3, and 2 back. Those make great numbers for examples. So if I have 4 plus 3 plus 2, what I'm going to show you, or what this rule shows us, is that it is equal to if I were to move those around. And there's a lot of different ways I could move them. So let's put, instead of last, maybe the 2 will be first, and then the 4, and then the 3. I could have also put 2 and then 3 and then 4, or I could have put 3 and then 4 and then 2, or so there's lots of different ways that you could write that. The only real thing you have to make sure of is that you do in fact move them. So these are still going to be equal, and I'll show you that in just a second. We'll use the order of operations and solve them. But let's write ourselves a little note here. And if you have color while you're doing this, you might want to add color, even if it's just a highlighter, to some of the rules or notes or things so that they stand out on the page. So moved the numbers to a different spot in the expression. Okay, so now let's go ahead and prove that this expression is equal to that expression. So 4 plus 3 would come first, so that would be 7 plus 2. And 2 plus 4 would come first over here, so that would be 6 plus 3. So 7 plus 2 is 9, 6 plus 3 is 9. So they are still equal. And that's what this rule is proving. Okay? This rule also works with addition and multiplication, just like the associative property. So if we were to do 4 times 3 times 2 over here, and then let's change up the order and we'll do 3 times 4 times 2. Okay, so order changed. Let's make sure that they're still equal by using order of operations to solve. 4 times 3 would be 12 times 2. 3 times 4 would be 12 times 2. So this one, based on how I wrote it, it ends up with this is even the same, which doesn't always happen. See up here where the 7 and the 2 weren't the same, but turns out the sum was the same. So let's make sure we have equal products. So 12 times 2 is 24. 12 times 2 is 24. They are equal. All right. So I changed the order, but it didn't change the value. So the commutative property rule says if we change the order of the numbers in the expression, it will not change the value of the expression. So this side is still going to equal everything on this side, even though we changed the value that we wrote them in. And this one also only works with addition and multiplication. So if you think about some examples, or maybe non-examples, of division or subtraction problems, the order that you do those problems in matters. So that's why those don't work with the commutative property. This is our third and final math truth or property that we're going to talk about in this lesson, and it's the identity property. So, oh my gosh, like the news is always talking about stolen identities, and your identity is like who you are, right? And so the same, sorry, the iPad stopped recording because I didn't have any storage. What I was saying is that your identity is who you are as a person, while a number's identity is who a number is, and what a number is worth. So the identity property is looking at how do we do something, some operation to numbers, but without changing its identity. So let's write down that identity is who you are. Identity is who a number is. So if we wanted to take 4, for instance, and we wanted to do something to 4, but in the end, we still wanted to have 4's identity intact. Can you think of something that we could do, some math operation we could do that would leave 4 as 4? That's right. You guys are so smart. We could add 0. So 4 plus 0 is equal to 4. In fact, oh, great. Lots of interruptions today. So as I was saying, we can add 0 to any number. We could add 0 to infinity. We could add 0 to 3,752. And it's not going to change the identity of that number. 3,752. I could even start with 0, and I could do 0 plus 148. And I'm still going to get 148. Okay? So if I add 0 to any number, I'm going to be left with that number. So it doesn't change the identity. Can you think of some other operation that we could do to 4 where we would be left with 4? Yeah, gosh, you're a rock star today, on fire. Multiplying by 1. Anything times 1 is going to be that same thing. So multiplying by 1 doesn't change the identity. So I could do 3,752 times 1 equals 3,752. I could do 999 times 1, and that will equal 999. So the operation of adding 0 or multiplying by 1 doesn't change the identity of the number. Now, this property is a little bit different name based on whether I'm adding 0 or multiplying by 1. So this one here is called the identity property of addition. And this one here, I bet you know what it's going to be called because you're so smart. Identity property of, say it. Yep, multiplication. So the identity property basically tells us that we can do some math to a number and not change its identity. Okay, so I just added that the identity property of addition, we add 0. The identity property of multiplication, we multiply by 1. So the rule says I can either add 0 or multiply by 1 and not change the identity or value of a number.